Welcome everybody. Welcome to today's educational program, Securing the Industrial IoT Ecosystem, brought to you by IoT World and sponsored by Blackridge Technology. I'm Lucian Fogoros. I'm the co-founder of IoT World, and on behalf of my team, thank you for joining. Our co-founder Carolina will monitor the online channel, so feel free to send your question in the chat line or via social channels, Twitter, LinkedIn, using the hashtag ICS_IIoT. Now I'd like to introduce our moderator, Greg Orloff, the Senior Analyst and CIO, your host for this virtual conference. Welcome, Greg.
Thank you, Lucian. Thank you. Good morning, good afternoon, and good evening. Thank you for joining us today. IIoT World is a digital media publication that covers the economic and technological implications of the transformation taking place as industrial IoT proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the IIoT. K-Core Analytics has recently ranked IIoT World as the #1 global influencer on several topics that include industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. IIoT World's mission is to help companies create a culture of innovation and connect the smarts, industrial technology, manufacturing, sensors, and CXO decision makers. Today we have an exciting panel of presenters representing TAG Cyber, Blackridge, and National Instruments. In this 90-minute virtual conference, our speakers will focus on securing the industrial IoT ecosystem, delivering the right information at the right time to the right person. Our first session is OT security, convergence, and cyber risk. And our speaker is Dr. Edward G. Amoroso, founder and CEO of TAG Cyber. In this session, Ed will address the cyber risk involved in the OT and IT security convergence and the resulting increased consequences of a successful attack. Ed Amoroso is CEO of TAG Cyber, a global cybersecurity advisory, training, consulting, and media services company supporting major organizations across the world. Ed recently retired from AT&T, beginning his career in Unix security at Bell Labs and culminating in his role as SVP, Senior Vice President, and CSO from 2004 to 2016. He was elected AT&T Fellow in 2010. Ed is also adjunct professor of computer science at the Stevens Institute of Technology for the past 3 decades. He's a distinguished research professor in the Center for Cybersecurity at NYU's Tandon School of Engineering, and also a senior advisor at the Applied Physics Laboratory at Johns Hopkins University. Ed holds a BS degree in physics from Dickinson College, as well as a master's and PhD in computer science from the Stevens Institute of Technology. Ed is a graduate of the Columbia Business School, and he served previously on the board of directors for M&T Bank and the NSA Advisory Board. Please join me in welcoming Ed. Ed, the floor is yours.
Well, thank you so much. Such an honor to be here with all of you, and I'll try and share some trends on industrial internet. You know, I wish you could see what a wonderful place I'm sitting in. I'm actually in Brooklyn, right near an airport where there's industrial IoT. There's quite a bit of industry sketched around here. I'm actually sitting out in a courtyard, and it's like I feel like I couldn't have picked a more IIoT setting for the discussion. So it certainly puts me in the mood. You hear a little bit of rumble in the background. That's the airport. So let me take you through this. This is one of the wonderful bright spots, I think, for the cybersecurity community, the work that we're all doing to try to protect what we, there's a lot of different things we refer to. A lot of times we'll say OT, we'll say IoT, and we'll say IIoT. And we sort of bounce between interpretations of it. But what we're talking about here is tangible infrastructure, connected up to modern computing and brought in band to cyber attacks through that connectivity and through use of software. So I'd like to show you 3 things that I believe, in my mind, now as an analyst, are worth keeping in mind. And I'm sort of speaking both to the vendor community, to the CISOs that are out there dealing with this, is also hopefully to some industrial engineers who've taken an interest in cybersecurity. Just as a parenthetical comment, I'll say that I'm glad to see many universities starting to combine some of the curriculum that it has long been separate. You know, it was always rare that you met an industrial engineer who could talk much about computing, and I think that's changing. So I'm glad to see that. But let's go to the next chart here with my first trend, and it has to do with convergence. I want to tell you a little story. If you share a generation with me, which means you're old, then you remember that in the 1990s, there was a local area network technology, a protocol called IPX. It was associated with Novell technology. So if you were running NetWare on your local area network, then you were running IPX. And it seems so funny to think now, but I want to say Novell might have had 3/4 of the market at one point. And what this meant is that the picture that you're looking at here was more or less what the internet looked like from your IPX implemented local area network. You were running one protocol and you had to somehow translate it to another. And you had a lot of gateways. You know, at the time I was working in Bell Labs, we were building something called NetWare Connect, which was both tunneling over the internet and somehow getting your IPX to connect up with websites. But I think that analogy and that idea that you have these two separate technologies reminds me of SCADA today and reminds me of OT, where you have this IIoT gateway. A lot of you very familiar with it. A lot of vendors focused on that. And there's translation. So you're going from the things we're all familiar with, you know, common TCP/IP stacks on networks and on systems. And then you hit that gateway, and suddenly you're in SCADA land, where you're talking Modbus, CAN bus, some crazy proprietary technology to a bunch of turbines or to engines or to a factory floor, whatever it is that you're dealing with. That's a very common setup today. I believe that just as IPX kind of went away, I think that IIoT gateway is going to converge into something that looks very in-band IP. I don't know how quickly, but I see it. I mean, if any of you were starting a company now to build some sort of industrial equipment, you know that it would be very cost effective and convenient to build native IT support into those devices. It's just cheaper. You'd drop Linux operating systems, you'd put an IP stack, and you do the types of things that make that OT device look more IT. Reason I bring that up is because I think that has to factor into your planning. Like, as you think through the architecture of your OT infrastructure and your IIoT deployment, I wish I could tell you how soon, but I think I know how the movie ends. I really do believe that just because of cost considerations, flexibility considerations, extensibility, and just the natural progression that we see in technology toward the, you know, common belief that IT eats everything, you know, like a little Pac-Man eating all other technologies. I think that's going to happen in OT. Now, I think it's a good thing because it'll allow us to take advantage of all the native tools that we've got in computer security, you know, next generation insert name of capability, next generation firewalls and multi-factor authentication systems and encryption. I think those increasingly are going to apply natively and directly to IT. That's good news. I think that really will make for a more common, more uniform architecture for all of you. So factor that in. You know, we can talk some more as you folks have some questions during the Q&A portion. I can certainly give you some more color on that, but that would be the first trend that I think is worth keeping in mind. Let's go to the second chart here. So this one has to do with consequence. You can see a picture there of someone driving around a curve. Let's face it, you know, you really can't generalize, but I'm going to do it anyway. The consequence of cyber attacks to OT, in the vast majority of cases, is more intense and potentially produces more catastrophe, perhaps even loss of life, than you're likely to see in a common enterprise IT environment. That's just a fact. So you work in a bank, you work in in an office environment, you're a lawyer, you're this, that, and you think of the worst case scenario, they can be pretty terrible, right? They could be, have impact on society. They can cause businesses to go out. They can cause your firm to go bankrupt. They can cause you to lose your job. But it's not often the case that, many or tens or hundreds or thousands of people will often die as a result of some consequential attack. Once we get into that OT realm, I think we all know that that's not true, that we do introduce some pretty serious consequence in a number of different scenarios, including transportation, including factories, certainly including power, nuclear being maybe one of the more obvious environments where the consequence here is maybe pretty unprecedented in the work that we do. So in the past, we hid behind that IT-OT separation. And anybody on here who's been studying cybersecurity knows that hiding between, say, a security through obscurity technology, where I cross a boundary and now I'm into some tech that we hope the hackers don't understand, that's a terrible way to protect infrastructure, just absolutely horrendous. So we know that this consequence is going to drive risk up because you do the math, right? The equation is simply whether the probability or consequence goes up, your risk goes up. So as consequence goes up, your risk goes up, period. What this means is to be pretty serious about this. I've been around a long time doing cyber, and like all of you, I've seen the casual approaches that exist in some companies, not all. And look, you guys are all listening to this awesome webinar. You're probably the cream of the crop. I find that people who take the time to learn usually are parts of teams that do it right. So I may be not exactly preaching to the right group here, but there are a lot of sloppy infrastructure and a lot of sloppy systems and a lot of potential catastrophes. Look, just take the 737 MAX, right? I mean, we can see the consequence of computing when it goes awry. The takeaway here is simply, when you think IIoT, I think you should think risk consequence. That's what I do. When I see it, that's the word association that goes on in my mind, that the consequence of what we do has just gone way up. It's the difference between, being the security guard in a candy shop and the security guard at Tiffany's. They are different. Theft in one is minor, theft in the other is pretty significant. So keep that in mind as you do your security engineering work, that it's not just a matter of, we're going to go in-band on the, with the IP, so we'll just roll the same architecture in and, everything will be just more or less an extension of what we do now. Even if that were true, the consequences are so severe that I think we need more. And I think what we're going to find is that the architecture will either be top-heavy on the OT side, or you'll raise the low water mark for everything to account for any OT that exists in your infrastructure. So for example, if you work in a pharmaceutical company and in the past your plant manufacturing infrastructure was completely separate from IT, well, you might have IT risk over here in your left hand that might be low, OT risk over here on your right hand that might be high, and gateways that separate. When these two things come together, when they converge into one common technology, which again is my prediction, I think the high water mark, or the low, I guess I should, low water mark, rises, and the least risk that you see will be, wherever you sort of sit on that spectrum of IT/OT. So if you introduce IT into the network or OT into the network, it's going to raise your risk consequence. So I hope that makes good sense to you. Let's go to the third one. This is sort of an interesting one. So I suspect many of you are familiar with the Purdue model. If you're not, probably worth, downloading a paper and just kind of going through it. It's sort of like this model of the Earth, right? It starts down at the device, and then you step away from the device into SCADA land where you're doing supervisory work, and then it goes up into sort of the OT control environment, and then there's a gateway, and then there's a network, and then there's the larger IT context for everything. So when you're talking OT security, I think most of you know this, but it's worth just reinforcing. You're doing one or more or all of those things. And, you know, often you get into these conversations with people who are running OT infrastructure and you say, gosh, what's your security approach? And they'll say, well, I run a data diode at the gateway. And that's great. That's a good idea. You know, I'm all for that. But that's one little piece of a layered architecture where, frankly, you probably ought to be doing at least something, you know, in each of the different layers of the overall architecture. It's probably not going to be enough to just do one thing, just as we all learned it was not enough to put security at your perimeter. So here's the takeaway for me. Do not fall into that same mistake where you just protect the perimeter and you don't, you know, sort of do an end-to-end approach. I think later on you're going to hear from Mike over at Blackridge. I love what they're doing. You know, you're going to enjoy hearing how they've embedded security into the TCP layer. And when I saw that, first thing I thought was, wow, that is a pervasive way to do it. I think it's a good example of, you know, not just being focused on, hey, let's drop a box in and protect OT from the bad guys. Look, we've learned that doesn't work. We call that perimeter. Everyone on this call would agree that there's at least some degree of deperimeterization or dissolution of that perimeter going on just about everywhere. So for OT, let's not make the same darn mistake again. Let's make sure that as we deploy protection controls and infrastructure to deal with OT risks, that we do it at the inner core, the outer core, the mantle, the upper mantle, the cross. You can translate that to your OT stack, or if you don't have one, use the Purdue model. It's perfectly fine. But use some sort of model that layers out the technology from core out to your surrounding ecosystem. Let's go to the last chart here, and I'll just kind of summarize. I think this, you know, this idea that there are these three sort of issues. There's convergence, there's risk consequence, and there's layers. You know, that for me, I think you should pick your own way of talking about this. And maybe it's this, maybe it's something else, but recognize that OT security is rich. It is not a one-dimensional sort of thing. This is a very rich, vibrant area of cybersecurity, and it deserves some thought. Now, there's two words here that I want to just highlight it before I close and hand it off to Greg to take the next piece here. One is automation, one's connectivity. So look, we're not going to be able to protect industrial infrastructure with manual computing and manual procedures. It's not going to work. You know, modern infrastructure is moving toward more agile, more rapidly deployed capability and features. So you might as well just accept that you're going to have to automate as much of the protection as possible. And then that word connectivity, I think, is absolutely essential, because as we talk about, say, zero trust architectures and device to cloud, it really is about connectivity, right? It's this idea that in the old days, I remember an old telco, you'd walk into the basement of a telecommunications building, you'd walk up to a big red button on the side of a wall, and boom, you'd hit that button and the generators would fire off. And if you would ask somebody, you know, gosh, can I hit that red button from my computer at home? You know, the ops folks would have fallen into laughter, you know, at the idea that you would be able to do something like that via remote connectivity. Today, that remote access is in place. And it really does underscore all of these different points that we've connected our infrastructure. That's the I in IIoT. And it's our responsibility as a group and as a community to take these things seriously, to recognize the convergence, to deal with that consequence, and to build a nice layered security protection solution in for the OT systems that you're responsible for. So with that, I'm at about 20 past here. I don't want to go past my time. I'm going to hand it off to Greg, who's going to take you through some very interesting technology. I'm going to stick around, so if you have some questions towards the end, more than happy to answer some questions on anything I may have shared. So I'll pass it off.
Great. Thank you, Ed. Yeah, I love the analogy of the converging railroad tracks and the IT Pac-Man perspective. You gave us quite a few takeaways in that one. First and foremost, my takeaway was OT security is not a one-dimensional thing. Thank you. So our second session is a new approach to segmenting and securing the IIoT ecosystem. And our speaker is Mr. Michael Murray, the Senior Vice President and GM of Cyber Physical Systems at Blackridge Technology. Current solutions from many vendors focus upon VPN tunneling style solutions, which gate the richness of the IoT data analytics due to encryption and deep packet inspection, creating latencies in the network. Furthermore, they are very expensive and do not address the deep layers of the network in an effective way. This session will discuss how these challenges can be overcome by microsegmentation and better security policy enforcement using authenticated connections and identity. Mike leads the cyber physical systems team and the industrial Internet of Things and industrial control systems ecosystem business for Blackridge Technology. Prior to joining Blackridge, Mike held several senior leadership roles at Analog Devices, and most recently TDK, where he was responsible for developing sensors, software, and machine learning system solutions. Michael has firsthand experience in leading multinational hardware and software engineering teams, as well as product marketing and sales organizations. He is also a successful veteran in multi-billion-dollar global mergers and acquisitions. Mike earned his MBA from the Sloan School of Management at MIT, a master's degree in technology commercialization, and a bachelor's degree in management from Northeastern University. He also holds an electrical engineering degree from George Brown College. Mike, the floor is yours.
Thanks very much, Greg. I appreciate it. And thank you for all of you who have joined. I'm going to start off with just a brief discussion around economic asymmetry and why IoT has a distinct advantage to the attacker. When we used to spend millions, billions, maybe even trillions of dollars in IT, commercial networking security, we hadn't been spending or even focused on IIoT or operational technology security. So most of the infrastructure in the United States and our allies today is aging, one. Two, it was never built with security in mind. And three, it is the significant problem that we still need to solve in IIoT and IT to OT convergence. The reason I say that is we can have new technologies that come into an infrastructure that are more secure, built with security in mind. Thinking about PLC controllers as an example, which my friend Ian Fountain will go through at National Instruments in the next session here. But ultimately, we still have an issue of what's called the brownfield. And the brownfield or legacy type of equipment, that capital expense that has already been paid for, is being utilized here in the United States in our factory process and building automation networks, as well as our critical infrastructure like water, energy, transportation, and telecommunication. Those networks, the cost to attack them is very, very low. Moreover, the sophistication to attack them is very, very low. Now, the cost to attack a multi-system IT infrastructure from afar is quite high. The sophistication to do so is also quite high. Now, every dollar that we put into IT consumer or commercial type of infrastructure in terms of security, we get back maybe even threefold for every dollar that we spend in terms of security. Now, on the OT side, we haven't even started that yet. So a lot of the attack surface is slanted towards the attacker versus the defender. And part of that is just simply because of our legacy equipment that was never built with security in mind, and quite frankly, is woefully insecure, non-secure. So as we connect these systems in the IT to OT convergence for the richness of things like condition-based monitoring, mean time between failures, and just overall IoT type of practices, I call it digital exhaust, which is something that I think in a factory automation setting we're seeing a lot of. That competitiveness we need to have here in North America and with our allies in terms of manufacturing capability, as well as utilizing our critical infrastructure. That economic asymmetry is what's holding us back. The reason why economic asymmetry is holding us back is the threat surface is so large here in the United States and in our allies that it's starting to gate the progression of IoT. So as it gates the progression of IoT, that gates our economic competitiveness as a country and with our allies. So the cost to defend versus the cost to attack and being resilient in there, in that cyber gap that we're seeing, is where Blackridge fits. And why I joined the company, my background, just briefly, is making the analog to digital converters, the sensors, if you will, for manufacturing firms and industrial firms globally. And what I wanted to focus on when I joined Blackridge was how can we create that digital thread at the beginning where the data starts in the IIoT or IoT? How can we then create authenticated identity that we can have a higher degree of trust and pedigree around that data for things like analytics and mean time between failure and condition-based monitoring? So with Blackridge, it's a very interesting opportunity, and how we do what we do happens to be a perfect IoT solution to the brownfield as well as the greenfield, or legacy versus new technologies. Next slide, if you will. Here in the States, even the Homeland Security came out with a special security tip talking about segmenting and securing network infrastructure devices and how to do that. Some of the benefits that they've been talking about is how to segment and segregate networks and functionality, as well as limiting unnecessary lateral communications, so east-west type of discussions and data transfers, and then how to secure the infrastructure devices themselves so that we can perform out-of-band network management. So part of that part of this all revolves around authenticated identity. Without authenticated identity, you don't necessarily know 100% of the time what you're segmenting or segregating, or what data you're getting is really authenticated and even useful. In some cases, we're starting to see data spoofing to disrupt analytics and make them less viable. And specifically in IoT or industrial IoT, false positives is something that we cannot have, because one, in a factory setting or in a government setting, a false positive creates an awareness to the people using that technology to ignore it moving forward. If it gets ignored, it's not any good. So you only get one shot at that, and unfortunately, our adversaries know what that means, and they're very much able to disrupt that. So you'll probably start hearing about, if you haven't already, the zero trust approach starts with authenticated identity in IoT and IIoT. And really what this means is, can we trust the current environment that our network exists in? Now, the interesting thing about IIoT, or Industrial Internet of Things, is when we start thinking about how to trust this network, when you have people outside of your perimeter, meaning access to an HVAC controller on the top of a building or the side of a building that is connected to your network, or the people that come in to maintain your maintenance line or your factory production line that get scanned in by a card and are never really checked that well, but they have access to things that are connected into the network, into the OT, and then ultimately into your IT network. So you have all of these multiple different ways to access a network, and that perimeter that Ed correctly talked about really doesn't exist on the OT side, because you've got these things, these carbon-based entities called people, that can access it in multiple different ways. So with that, thinking about a zero trust approach is the best way to think about your networks on the OT side and IT side, in my view, and talking about how to make sure that you've got authenticated identity and authenticated connections into your most critical areas of your network. So being able to create that data integrity is absolutely important for algorithms and development thereof, but the ability to enforce rules and policies over time as new technologies come in, and being flexible as new technologies come in, and flexible for older technologies. Quite frankly, there's still PLC controllers being bought and sold today and implemented in new networks that were created 10 years ago without any security in mind. So those types of generations of devices are still being used today. Now, the permissioning capability that Blackridge has, I think I will be talking about in the next few slides, really creates that permissioning and asset scanning. The ability to cloak or conceal network devices, I think, is critically important. When I talk to customers, there's usually one or two systems that they're really interested in securing and making sure that adversaries can't see or scan or map them. The rest of the network can be segmented in a way where threats can be contained in a certain manner. So that's the flexibility that customers are looking for, and the flexibility for I think the adversaries that they do not want to see. And then again, talking about brownfield, everyone that I've talked to in the industry is very much focused on new technologies to solve some of these issues that will be coming out in semiconductors, like hardware root of trust as an example, over the course of the next 3, 5, 10, 20 years. That's all well and good. However, we still have this infrastructure that was already bought and paid for, that is already being connected or not connected because of fears of security and IP compromises, that customers and government agencies want to connect, but are fearful to connect them. So that progression of IoT is being gated. Therefore, our ability to be competitive on a global stance is also being gated. Next slide. So this is what I talked about, simply put into graphical view. When you think about a legacy system, it's a tapestry of older sensors, controllers, and trust policies. Most often when I go talk to factories as an example, or better yet, critical infrastructure, and I talk to CIOs, which I've had the opportunity to tour around the last few months and talk to CIOs, they always tell me, Michael, we don't know necessarily what's in our network because we just acquired this company 3 months ago and it has a completely different network architecture. And then the manufacturing side, we are not sure what's going on there because there's 3 different factories in 3 different countries, all connected through a tapestry of older sensors and older networks. So we're going to get to that point, but our first rule of thumb is we need to integrate this company as an acquisition. So that was one thing that resonated with me is most CIOs these days are more interested in keeping their systems up on the IT and OT side of things. And now they're moving towards, okay, we're now compliant, maybe to the rules that are out there for our given industry. But now we need to move to, we're compliant, but are we secure? If you go to the next slide, we start thinking about how to segment a network or segment our OT and IT environments in a way that we can take a look at older legacy technology that we do not have a trust level for. Moreover, we're not going to influence the cost to secure them or put any sort of higher level security around them. We're going to give them a different trust level, a different pedigree level that normally we wouldn't. So with this type of architecture, we can now look at our IT and OT ecosystem and say, these are the technologies that I'm going to trust at a higher level. I'm going to create policy and rule engines around them versus technology that I know are inherently not secure. And I'm going to be able to give different rules and policies and access to certain people based on not only the person, but also the technology and the gear that they're using. And over time, I'll be able to move these sectors that are red or yellow into more green sectors where I value and trust the authenticated connections that I'm getting from those devices in certain ways. So this takes into account the legacy brownfield environment that I spoke about earlier, plus the new technologies that are coming in. And when I talk to CIOs and plant managers about this, it's interesting to get the different views from a CIO or a plant manager whose sole job is to make sure that the plant doesn't go down and the timeliness of that plant is still competitiveness, where the CIO doesn't want to be put up on the front page of the New York Times about losing IP or customer data. So those things are now merging, but at the end of the day, it's still about competitiveness, about running a business. And latency in these networks is extremely important, specifically on the OT side. And the perimeter that Ed correctly talked about on the OT side is very difficult to extend and trust. Next slide. So talking a little bit about Blackridge, we're about a 50-person company. We are focused on IT and OT, infrastructure, networking, and security. But it's interesting because how the company started was with a Department of Defense contract, and it was an early IoT problem. And the problem was exactly this. Our adversaries learned how to scan and map IP addresses and ports. So when they got good at it, they were able to actually understand the connected soldier and the connected asset on the field. Now they can scan, map, and track all of these assets using IP addresses and port scanning capability that our adversaries now have and have had for a number of years. They got so good at it that they were able to actually track troop movements, count how many troops are on the battlefield, what sort of assets were on the battlefield, and then work to either penetrate those assets from a IT or OT type of hack, or just understand where the troop movements were going and create solutions for those troop movements. So that was how our technology was developed and why. And it just so happens that there was a very early IoT problem, but now the way that we can connect after we authenticate versus the way the internet works, which is it connects then authenticates, just happens to be a great solution for multiple things like machine-to-machine technologies and IoT. Next slide. So how we do that and why we do that is becoming more important because the progression of IoT attacks is increasing. And as Ed said earlier, which I think is very, very correct, is not only is the frequency of these attacks increasing, the complexity is increasing, But now the consequences of these attacks are also increasing, because not only can you have a disruption in your downtime or effectiveness as an asset or a company, but now you'll have denial of service, loss of intellectual property in the case of some of the manufacturers that are out there that have lost IP, their customers' IP. That trust level between and intimacy between your customer and your company then takes such a significant hit that it's a costly harm to your asset, but also your reputation as a firm. But more importantly than anything else, in the OT side of things, because we work with machines that spin, move, carry things around, as well as maybe transport or switch high degrees of electricity, or on the water side of things, it's actually the only commodity that we consume as human beings that's controlled. Water, energy, transportation, and telecommunication grids are all filled with the same PLC controllers that were built 10, 20 years ago without security in mind. This now becomes a life-saving issue. It is now a safety issue. As an example, there's multiple blogs written about how to control a robotic arm to make it swing to the opposite direction, and how to do that using code that's available on the internet. I encourage you to Google that. That is very much an issue, and it's just one specific aspect of some of the threat surface that's evolving over time. And as you can see from this chart, the amount of attacks and complexity of those attacks is only increasing, because it's easier to attack an OT environment than it is an IT environment. Moreover, the ability for an adversary to learn about that technology and learn how a PLC controller works, as an example, is much less costly and certainly much less complex than it would be from a IT consumer or commercial type of environment. So this is the type of environment that we find ourselves in. We have to deal with the brownfield environment, and we have to deal with how the internet inherently works. How the internet was developed was not supposed to be the way that it is being used today. It allows you to connect before it authenticates, and at Blackridge with our technology, we make it authenticate before it connects. And it gives the user the ability to understand who, what, and why is connecting to their network. And that's, for IoT, something that's very innovative, and we'll talk about how we do that in the next slide. So Blackridge, we have a patented differentiation in the market, and we really focus in on the first packet of non-interactive identity authentication. How we do that is we insert identity tokens into the TCP IP stack. This takes away or conceals the port scanning and attacking ability away from an adversary, and that happens during the TCP IP session setup. It's a very low latency type of architecture. It's something that we're quite proud of. And on the IoT side, specifically talking about machine-to-machine or IoT applications where there's a user involved, it just happens to allow users as well as network administrators the ability to authenticate connections before they allow them to enter the network. And from a brownfield standpoint, it allows us to detect and defend very easily, working with current infrastructure, as well as we work with new technologies. It allows our companies and customers to adapt their identity authentication over time, and certainly their security profile over time. Next slide. So how we add identity-based protection is in multiple ways. One, we have what's called attack identity device. It sits in between or in line of a PLC controller or a microcontroller or motor. And then we insert identity at that point, and we can resolve the identity later on in the network, either at a gateway or a virtual gateway sitting in the cloud. And we have commercial devices as well as an industrial device advocacy that we're working with. But more importantly and moreover, we're now looking at how we actually can use system resources within a PLC controller, an existing PLC controller, and port our code into an existing PLC. Now, a programmable logic controller by nature is programmable. And because it's programmable and it has a TCP IP Ethernet connection, we sit alongside that normalized TCP IP header and stack. We don't necessarily get involved with how that function works. We insert our identity and token in that header without having to mess with a standard TCP IP session. So with that, we're able to create identity policy enforcement for incoming traffic. It provides a two-way protection from network scans and attacks. and we have an IoT security solution for brownfield environments and, of course, for new environments as well. So as we move forward, we have an advocacy and engineering capability to move into embedded TAC for embedded appliances, working with things like hardware root of trust over time, but more importantly, working with the environment that a PLC controller finds itself in, with the resources within that PLC controller to port our code to that asset and inject identity at the edge, at the very edge, where the analog to digital conversion starts, where that digital thread begins, and provide that to our customers so that they can resolve the identity, do things like microsegmentation and segregation, and create that higher level of awareness and higher pedigree and provenance of data and trust within an OT environment, while still working with our IT product line and making sure that that IT to OT convergence happens seamlessly, safely, and securely. Next slide. So with that, I'm going to hand it off back to Greg. I'll be around for more questions, but I've worked with Ian Fountain for a number of years, and the things that are going on at National Instruments are truly exciting, and I think they're one of the leaders in highly assured data, and that's why it's been a great partnership for us at Blackridge. So Greg, back to you.
Great, thank you, Mike. Wow, authenticate before you connect. My takeaway from that one, indeed. So this takes us to our final speaker for today, Ian Fountain, and he is the Director of Marketing for Industrial IoT Applications for National Instruments. He'll be walking us through his presentation entitled OT Data Trends and the Smart Factory. This talk looks at sensor and data-centric technology trends that are helping solve the challenges of integrating OT equipment into a valuable part of the company's digital journey. Real-world case studies and test beds will be used as examples. As the Director of Marketing for Industrial IoT at National Instruments, Ian is responsible for the company's global business in monitoring and industrial Internet of Things applications. He's heavily involved in the strategic development of the associated products required to address customers' needs. Fountain joined National Instrument in 2000 as an applications engineer. In 2001, he moved to Southern Colorado and became district sales manager. In this position, he focused on evangelizing virtual instrumentation and developing key regional account relationships, including Lockheed Martin, EcoStar, and Atmel. In 2004, as business development manager, Ian took on development of National Instruments' hardware-in-the-loop strategy. As a result of the success, National Instruments increased investment in this application and is now considered a key player in the market. Fountain holds a Bachelor's of Science degree in Electrical and Computer Engineering from the University of Colorado. Ian, the floor is yours.
All right. So appreciate the opportunity to address everyone, and I look forward to hopefully providing some good examples of how we've seen some of our customers actually deploy some of these IT, OT technologies and achieve some business impact. So kind of, building on what Ed said from a, let's say, a philosophical perspective of what's going on from a security perspective in the OT world, and then my friend Michael adding a little bit of the tangible mapping to technology that's available today. And what we're going to try to show is how some of those technologies can actually impact your bottom line and help you save money. So for those of you that don't know who National Instruments is, we're a company that's been around for over 40 years. We're headquartered here in Austin, Texas. And last year, we're a publicly traded company, and last year we did over 1.3 billion in revenue. We do that directly with our customers. We have what we call an engineer-to-engineer model. And the reason why that's important is because as you're deploying technologies, as Michael's alluded to, there's a lot of complexity in these devices, a lot of complexity into the applications. And we found that partnering with you and helping you to select those different components as part of the solution is the best way for us to jointly grow together. Part of what we also do is have a very aggressive investment back into R&D, and as part of that investment, we're constantly trying to challenge ourselves to be the best that we possibly can. And so we've been an early mover, I would say, in the OT space, moving our industrial edge devices to security enhanced Linux as an operating system, and then looking to partner with the best in the world like Blackridge to make our security strategy even stronger. If we go to the next slide, we can see, I guess, some of the reasons why we feel like security is critical. National Instruments is engaged in some of the biggest topics and trends that are happening today, like 5G, heavily involved in the automotive industry and supporting customers and businesses and their goal to add autonomy to those vehicles. And of course, we've all seen some of the research that's come out about how some of the cars can be hacked and people can take over control of things from a research perspective, and control brakes and different subsystems of the vehicle. And so, and then of course the industrial Internet of Things, which we're going to spend the rest of our time talking about today. But in all of these different avenues, security is a critical pillar that we have to be able to build upon. And so that's something that National Instruments is quite keen to invest in and partner with companies, because our perspective on this is that we can't do it alone. We need to do it in an ecosystem strategy, and that's what's going to work best for everybody. If we go to the next slide, I believe this slide animates, and let's go ahead and fill through all those animations and just go to the next slide here. This is something that NI is a provider of monitoring technologies, industrial, OT technologies that can be retrofitted into the brownfield factories, like Michael was referring to earlier. That's really the space that we try to operate in. Here's a couple of examples of customers who we've worked with, who have recognized the benefit of sort of the industrial Internet of Things trend, and deployed very large scale industrial Internet of Things solutions for asset monitoring and condition monitoring in their factories. And the returns that they're starting to see, as you can see, there's a couple of different ways that have been measured. Our customer, Louisville Gas and Electric, was focused on reducing the amount of time it took for them to get to an actual diagnosis of the health of an asset once the analytics algorithms told them that something was changing. Duke Energy was really focused on preventing large-scale catastrophic failures. And so, but both of them achieved a significant return on their investment. And both of them took an approach to retrofit new sensing capabilities into existing facilities already. And we've heard, when you're starting to add new capability, you could potentially open up new threats. And so this is an area that we're excited about, partnerships with companies like Blackridge to make sure that we're doing that in a moderated and acceptable approach. Next slide. From a smart factory perspective, other engagements with customers have really been focused on helping companies achieve higher overall equipment effectiveness. And so, many times companies are looking at their factory and saying, we need to get more out of this asset. If the factory can be viewed as an asset, we need it to be available to manufacture products more than it has been in the past, because we've got increasing orders, but we don't want to build a new factory. We want to be able to manufacture products more quickly, so that's a throughput measure. Or we have a challenge with our quality and our yield, and we want to address those. And so these are typically the bottom line, key performance indicators that factories try to hold themselves accountable to. And all three of these improvements, actually, if you look at what's going to help you move the needle in them, it's by getting access to new data and adding new data acquisition capability to this factory, and being able to oftentimes surface that data in a connected world to analytics experts that might be on the other side of the world. And so when you start talking about having access to data that might be sensitive and needing to be able to surface that data to somebody on the other side of the world so that they can apply their subject matter expertise to help you achieve your financial outcome. Certainly being able to trust where that data is going and ensure that it's getting into the right hands and not getting picked up on the way by an adversary is something that our customers care very deeply about. So next slide. This is another example where we actually worked in a large food packaging client, and they were applying additional technology after the factory was built. So again, a brownfield application to address both throughput and availability concerns. So they had some challenges with their the gearbox and the grinder that was used to grind up the plastic pellets that would go into the food packaging products that they made. And they were also having some challenges with their pneumatic tube feeding systems, keeping up with the throughput rates that they needed to run. And so they went through, studied those processes, added an additional layers of sensors, and once the additional sensors were added in, they needed to acquire that data and then publish it in a way that was secure in their IT infrastructure. And so National Instruments, through our comprehensive approach to that, we were able to partner with them and have an IT and an OT solution that met the customer's needs and helped them achieve a greater than 10 percentage point improvement in their overall equipment effectiveness. So many times companies will ask us, well, how do we justify these large IIoT projects? How do we explain to the chief financial officer that this large investment is going to pay off? And that's something that I think has been very eye-opening for me. How to bridge from sort of the engineering world, certainly through to the IT world and the topics of security, but then financially make that make sense for the company. And I think when all three of those can come together, you can really start to see significant traction and improvement in the industry. Next slide. Another demonstration that we did was work, and this one actually has been surfaced and featured many times in a number of different venues, but this was a partnership we did with Flowserve, who's an industrial pump manufacturer. And this is an example where an OEM, who would typically be selling what would have classically been a dumb asset, they wanted to work in an ecosystem approach to make their assets smart. And so for those of you that are on the phone that may not own the factory yourself or be in a power plant or oil and gas refinery, but you are working at an organization that makes products that you then sell to others, and you're thinking about making your product smart, this is an example showing a similar approach where you can very easily retrofit technology into your product and make it have all of the hallmarks of what's expected today from a smart factory. Smart appliance. It can have improved data connectivity. It can have analytics coupled with it. And in this example, we're actually showing advanced data presentation capabilities such as augmented reality or virtual reality. And so again, these are all approaches that can be applied today, as we've done in this demonstrator, and then you could start to surface to your customers. Next slide. So this, as I mentioned before, many of these environments that we go into, we find that we actually have to collaborate with a large number of different enterprises. That smart pump example that we just showed is actually a result of a collaboration of many companies, PTC, National Instruments, OSI Soft, Hewlett Packard Enterprise. And so I think one of the main lessons that I take away from a lot of these discussions is if you want to enable some of these large industrial Internet of Things projects, it's going to require an ecosystem. And I think having companies that take security as an important hallmark of their solution and are comfortable sharing with you what their security strategy is, and are comfortable having a dialogue with you about that is an important decision that you make when you decide which people you want to let into your ecosystem. And I know certainly companies like PTC and Hewlett-Packard Enterprise are companies that have that pedigree, and that's why we typically will partner with them. But this is just showing an example of a collaborative architecture where you can, start to get some of those best-in-class capabilities from a family of companies that can put those things together and actually deploy large solutions to the field today. Next slide. Another case study, this one is a good example in sort of the public sector. So this is one that we did with London Underground, and I think there's an animation here that you'll need to click through. So, oh, we skipped over that one. I don't know if you can go back, Lucian. Okay, great. So this is a situation where in the underground system in the UK, in London, they have a number of different circuit checking systems, which are actually ensuring that they don't have two trains on the same track at the same time. And in the past, they had to shut down the underground to go around and monitor and check to make sure that those circuit systems are actually working properly, or else if one was, as Michael mentioned, as one was reporting a false positive, they might need to shut down the system, and in which case it was just the sensor that was the problem. And so they actually retrofitted in a remote monitoring system that allowed them to increase the uptime, which then drove to about almost 40,000 additional operator passenger hours that they were able to achieve per year, which is a huge benefit for the City of London, and something that you clearly we're deploying this into an underground transportation system that's been around for quite some time. Next slide. And the last example I'll give is in a heavy industrial environment with China Steel. Again, applying a brownfield sort of philosophy here. They had a challenge that they were actually attributing about $11 million of loss per year. I'm sorry, over a 3-year period to unplanned shutdowns. And so in this situation, they were able to retrofit some sensors into the system and do predictive maintenance use cases so that they could actually understand when their assets were going to fail and plan appropriately, and they weren't having surprise maintenance pop up, which is surprise maintenance is oftentimes the most dangerous kind of maintenance and the most expensive kind of maintenance that you can have. Next slide. And so what I'm going to wrap up with are a couple of the trends that we're starting to see from a smart factory perspective, just to show you that, what we're hearing from our customers, what are they asking for, and what are we going to be investing our R&D dollars on. Next slide. So certainly in the examples that I've shown you before, these are very heavy industrial environments. They're brownfield. Retrofitting any sort of technology into a brownfield environment can be a very costly proposition. And so many of our customers are coming to us and asking us for a wireless capability, a battery-powered, wireless data communication capability. And so this is something that NI has been investigating for a number of years. We've got some products that are coming to market this year, and the concept behind these products is the ability to add new sensing modalities into your existing factories without having to run expensive conduit and cabling. Doing this in a secure manner is something that is very challenging. It's something that we feel the best way to do this in a secure manner is actually to support standards-based protocols as opposed to trying to do things on our own that are unique. I think the concept of security through obscurity is something that we definitely don't believe in. And so doing this in standards-based approaches is the way that we've been moving forward. So that's a trend that will help people with use cases like predictive maintenance or asset tracking environmental monitoring, and process optimization, which are all some of the largest paybacks for industrial Internet of Things use cases. Another one that I worked with Michael when he was at Analog Devices on is a lot of this MEMS sensor technology. This is allowing us to make measurements at a much, let's say, much more friendly price point. Being able to make sensors out of silicon at high volume is really what MEMS is all about. And recently, companies like Analog Devices and others have invested heavily to do that at a very attractive performance level. And so that's another trend that you'll see National Instruments leveraging to help, again, reduce the cost to install these new sensing modalities in these factories. Next slide. And then probably the one that people don't really initially think of, a lot of people think, okay, great, I've got new sensors in my factory, I've got new wireless communications that I can deploy to help reduce the cost of installing those new sensors. One of the things that oftentimes will surprise people is just the sheer amount of data that can be produced by these new sensors. In the Duke example, we added approximately 300 edge devices connected to about 3,000 sensors per factory. And if you actually do the math on the amount of data that we're producing with those sensors per day, it's over a terabyte of data per power plant per day that is being created by those sensors. And so certainly it's important to understand, how is your network going to handle that amount of data? Our belief is most networks won't handle that amount of data, and it's important that you actually do intelligent edge processing of the data to remove the useless data, and you're only sending the data that's important. And so this is something that NI has invested heavily in. Our security enhanced Linux-based gateways are where we do this edge processing capability, and it's something that allows you to ensure that your IT organization is only dealing with the important data that's required. All right, I think that's it for my slides.
Great, thank you, Ian. You highlighted some great examples. Thanks again for the insight and peek behind the curtain at National Instruments. That's a staggering number, a terabyte per day at a power plant. And the importance of processing that data and processing only the pertinent amount of it. So at this point, I'd like to now invite all of our speakers to unmute their lines for our open forum and Q&A portion of the conference today. Now, for all of you folks virtually attending, you can ask questions via the Zoom tool, which I think some of you have figured out based by the number that are coming in. And you can also submit questions through the social media channels using the hashtag ICS_IIoT. So I think we'll kick it off with the first question. This came in from Karsten. It says, what measures are being taken to provide physical security to distributed industrial edge applications? Well, I'll open that up to the group, whoever would like to try and field that one.
I'll jump in, Greg. I think it's variable. From a physical perspective, access identity controls are obviously a way that folks are thinking about things, but I think it's evolving towards more of a zero trust environment where you want folks either from a physical standpoint to be authenticated before they're able to connect to a network. Multi-factor is definitely increasing its adoption rate in OT. So I think those types of applications and thought processes are ones that I'm seeing most prevalent from a physical standpoint. The other thing that's interesting is analytics from a standpoint of video analytics, I think is an area where there's tremendous spend going on from a physical security standpoint, and there's a lot of advancements there. However, as they advance on the physical side or the visual side, the man-in-the-middle attacks still are prevalent. So we're working with a number of IP camera customers, as an example, to make sure that the IP cameras that are being used, and either in the brownfield and the new ones, are authenticated before they connect to the network, because that's a vulnerability that they create. So that would be my view at this point.
You know, this is Ed. Let me add to the point. I totally agree. Well, a lot of the physical security systems are themselves OT-based infrastructure, so that convergence, I think, is important. I recently interviewed and blogged about a company called Alert Enterprise. They're one of many that have done quite well trying to bring together and unify what traditionally was a gigantic gaping hole between physical and logical protection. So I think it's a great question because it exemplifies everything we're talking about, that if you do this right, then there ought to be a nice commonality between the physical and logical protections.
Great, thank you both. The next question that we had, this came in from the internet as well. And in use cases where small form factor edge compute devices are deployed, how does one ensure data integrity will not be compromised by unauthorized access to the infrastructure?
It's a great question. And it's one that everywhere I go, every customer I talk to, that's the question that is the most stressful for CIOs and plant managers. So in our view at Blackridge, any of those smaller devices, either you can implement what we call TAC ID as an inline micro device between the two devices, between the IoT device and your network. But we're also developing and have an advocacy for the ability to port our software into the IoT device itself using the hardware assets that the IoT device has. As an example, I used the PLC example. We're able to port our code and inject identity into existing PLC controllers using FPGAs as an example. So in many constrained devices, you might have a much smaller processor like an M4 or M0 type of application. I think we've got a strategy around that. And over the course of the next year, we hope to provide a product in that area as well with more constrained computing. The other thing that I would look to the team, and I didn't mention this earlier, is NIST NCCOE has a number of papers, and I'll use one, the ASP, so Apple Sam Peter 800-160 is a great paper on IoT device security, what can be trusted, what shouldn't be trusted, and things of that nature. And it gives a pretty good guideline and review of current architectures and how to adapt over time. So that's a resource that's available to you. I believe it's free. I would encourage folks on the phone to take a look at it and download it from the NIST website.
Excellent, thank you. The next question that came in is, how far were the original industrial communication protocols built with inherent security? And is it realistic to expect a standardized next generation protocol that can address cybersecurity more effectively in the near future?
I can maybe talk a little bit about some of the industrial protocols that we still run into, just to kind of maybe frame the question a little bit. I oftentimes am in facilities where people are using even protocols like RS-232 and RS-45 still. So, you know, to say that there's security built into those protocols, I think is probably laughable. And those things are still what is used to control a lot of the plants that are out there working. From a security perspective, as Ed mentioned in the beginning, a lot of people really had the perspective that OT was disconnected from IT, and security really didn't need to be thought of. Now that we're wanting all the benefits that come from the internet and the IT world, I think there's this tendency to just connect and not really put as much thought into it. But certainly I would encourage customers not to just connect without putting some security perspective in there.
And I'll hop into that one as well, just real quick, Greg.
Sure.
Predominantly on the industrial IoT side, we still see things like Modbus, Profinet, BACnet for factory process and building automation. On the wireless side, you're starting to see things like 6-low-pan, some narrowband LTE being more prevalent for longer distances. We do see some LoRa, which is a Semtech standard in smart cities. So depending on the IoT market, you may have different standards that you may need to understand their security profiles. I think where we're focused and where we see the highest degree of security issues is in the factory process and building automation markets, as well as critical infrastructure. And there's a different level of standard protocols that are out there. And I think National Instruments does a great job in creating universal I/O and I/O that is capable of taking in a lot of these different standards and creating digital authenticated identities out with real-time Ethernet and time-based protocols. So the other thing that I wanted to mention in that area, when we start talking about protocols, time is a big important factor when it comes to security. So secure time or realistic time, deterministic Ethernet is now becoming a byproduct or is a byproduct of security. So those things are changing over time, and National Instruments has a great program for that. That's why we like them so much from a factory automation perspective, because timing is an absolute issue when it comes to OT environments. You don't want to slow down a robot that you want to secure more than another robot that's down the way in the factory production line. So I just want to caution everyone, we start talking about protocols and adding security to them. Latency is an issue in this marketplace, and that's why I think the TAC ID and TAC for IC type of environment is great, because it doesn't add much latency to the network, but it still allows you to authenticate. So that's how I view protocols at this point. And I think there'll probably be a question around 5G. And I think 5G is going to be a democratizing technology and protocol for IoT. And it's something that is still nascent, though. And I think also we'll have the same problems that we currently have today, which is the legacy environment. That still won't change. So we have to fix that first.
Hey, Mike, this is Ed. How often do you see just vanilla Wi-Fi pop up in say, factory automation settings?
Unfortunately, too often, Ed. And I'll give you an example. I was at a customer, a very large scientific company who actually works in nuclear research. And what we found was that one of their engineers put in just a standard Wi-Fi box on their network to do things like engineering tests and what have you, and set up a test network with a bunch of IoT appliances. And guess what? Sure enough, it was a beacon, and someone was able to hop on their network and penetrate their network on the OT side up through their IT side. So the unfortunate thing is that I see it more often than I should. And it's a real problem, because people just aren't educated in what they're doing. Their intentions are great. In that case, the engineer wanted to set up an engineering network to do testing, but unfortunately what he created was a wide open door for adversaries to walk through.
You know what I fear is going to happen? I think people are going to assume that 5G comes prepackaged with a whole bunch of security and you're just going to be fine. And we all know that unless you SDN enable or add in the kinds of things you want, then the 5G connection it potentially could be just as bad. So that's going to be interesting to see how people treat or view 5G versus, to your point, the sloppiness of just throwing a Wi-Fi access point in place. Well, I guess we'll have to see.
I agree. It's going to be interesting. But again, it's still somewhat nascent on the OT side of things. But I do think from the vehicle-to-vehicle communication standpoint, it's going to be very interesting. And we're working with automotive-grade Linux right now to understand what that looks like and influencing those standards moving forward. But by nature, it's going to be or wants to be ubiquitous. And when things are ubiquitous, 9 times out of 10, the security profile is really on focused and pushed onto the user. So that's what I currently see. Could be wrong, could change over time, but it's definitely going to be interesting, as you say.
But I'll add
on that same level. Go ahead. Go ahead.
Sorry, I was just going to, on the wireless topic, I was just going to add that it's underestimated the cost of running conduit and cable in these brownfield environments. When with the Duke large-scale project that we were involved in, the cost of instrumentation and data aggregation and edge processing was in that environment, about a quarter of the cost of the conduit and cable required to support the new sensing modalities that were put in place. So, you know, $80 million of the project was the total project budget, and a full 40 million of that went to conduit and cable costs. So there's going to be a very high desire on the you know, the operator's side to reduce at all costs that conduit and cable, and I think it can be done. It just is to be done with security in mind.
Great points. There was a follow-up question or tangential to this from Mark. It says, has there been any established slicing in 5G yet for IoT secured channels?
Not that I'm aware of.
Okay.
One thing I would add on that point is that the essence of software-defined infrastructure is that you can make things extensible, right? That's kind of the whole point. So that northbound interface on an SDN controller and a 5G network is open season for entrepreneurs and developers and vendors to build out capability that the market demands. So let's hope that that promise of that open interface, you know, allows us to create capability without having to, you know, go through the pain of redesigning networks because we forgot something. So that's a good example of a capability I would hope that will be virtualized.
Yeah, and from my perspective, Greg, I have heard of some advocacies around network slicing in 5G. We saw it with 4G and LTE, a lot of slices of that network being segmented for things like narrowband IoT or LoRa, or even some of the ISM bands. Actually, ISM band is a better example of where network slicing was put in place in ISM for different protocols and different aspects of the market, meaning, you know, ambulatory or first responders or what have you. And those slices of the network were focused in on certain aspects of an end application. So I think 5G will absolutely get there. I know that there's a number of companies rushing into that space to get their slice, if you will, and own that slice so they can create their own, you know, standard or protocol unto themselves, or with a consortium of, you know, like individuals and like companies. But I haven't necessarily heard of anything so far. But I know that the major network gear manufacturers like Ericsson and I think Huawei have an advocacy around slicing that network for their individual or indigenous type of a purpose, so that they own part of the network for things like first responders and what have you, and IoT, since first responders, as an example, is an IoT application, and industrial IoT for critical infrastructure. So I see that as being more of a geoeconomic focus right now, or not geoeconomic, geopolitical reasoning right now, but it's going to go geoeconomic, where folks like those companies I just mentioned will want to own part of the band for IoT and IIoT applications. But I think it's starting geopolitical, meaning governments want some part of that band unto themselves for things like first responders, military, government, and what have you.
The poor man's version of that slicing in the old days was you reserved all the old crappy 2G or 3G for things like OT, right? I mean, I hope it'll be better than that, but that's what we used to do.
All right, this one came in from Gary. It says, is there a standardized list of KPI used in IIoT technology, such as one might use in a contact center, only focused exclusively on the sensors and data, and sets points that can be used to work towards enhancing overall IIoT system performance? So any thoughts on KPIs?
Is the question around security KPIs or just performance?
He doesn't specify, but Gary, if you're listening and you want to clarify, by all means jump in, but maybe we can address both of them at a high level.
Yeah, I think I'll just jump in on that one real quick. There's a document from our partner PTC, Peter, Tom, Charlie, or Parametric Technologies. I think it was their old name, but PTC is a National Instruments partner and a strategic partner to Blackridge. If you look at their website, they have a number of key performance metrics that they've developed with their customers around how to get the most of the sensors that are currently in the environment. They also have a partner program of which we are both in. I think National and Blackridge are both in their partner program to say, if you use these vendors, you'll get the highest pedigree, provenance, and real-time deterministic data from our partners. And here's some key parameters that you would want to strive for. And they do a really good job of that. I think they're one of the world's leaders in IoT connectivity and the ability to take IoT connectivity and actually do something valuable with it.
Excellent.
Yeah, I'm not sure. I was reading his question again. I'm not quite sure. You know, it looks like there's some focus around the sensors and the data and IIoT system performance and the KPIs that are used, you know, to sort of dictate system performance. And many times, system performance is well, almost always it's dictated by the actual end application. So let me give you two examples. One example that Michael's referred to a couple times is, you know, control. So controlling that robot arm or controlling the factory. Those are very low latency deterministic applications typically, and there's, generally speaking, very little room for you know, for mistakes or late packets. And so that's where National Instruments has put a lot of focus and investment around time-sensitive networking. So being able to interleave on a traditional you know, network, both lower quality of service communication, like what one might require for streaming a video, with very high quality of service control-based messages that you would use to, you know, control that robot arm, as an example. And so in situation, KPIs are all around packet loss and latencies and things of that nature. If you contrast that with the example that I provided with Duke, which is a predictive maintenance, you know, condition monitoring, asset performance type of application, in those environments or in those situations, generally speaking, you know, you're not trying to make a decision on a microsecond level. So we have a lot of resiliency built into our edge devices so that they can store data and forward it should there be a network interrupt in that situation. So the KPIs that are useful in that application are very, very different. So maybe that's getting to some of what his question is at.
I would think the interesting part of all this would be the impact of security functionality on acceptable KPI ranges. So you heard Mike earlier talk about dropping code down onto a device. You know, the presumption would be that Blackridge would do a nice, compact, efficient build, and it would, you know, not take up too much memory or introduce delays. That's what I would think, that in the context of our security discussion, that would be the key issue here, that, you know, as you add encryption, as you try to overlay authentication, as you try to harden the Linux environment, what the heck are you doing to my KPIs? That would seem to me to be the kinds of discussions that I would expect to happen between OT security engineers and the traditional industrial control engineers.
Here's an interesting question from Denny. It says, how is it best to provide vendor remote access and isolate them only to that machine, but also provide internal company employees like engineers access to the IoT device on the isolated subnet?
Well, this is Ed. I would say zero trust is something to look at. That concept addresses exactly what this person's question would seem to be focused on, this idea that, you know, you need some generalized means for gaining access according to some policy and set of rules. And that's no different for OT than anything else. So I think that, you know, the person asking would be wise to take a look at and probably is familiar with, but I think zero trust would be the right approach.
Great, thank you. We've got another one here from Raghavendra. I hope I didn't mispronounce your name. What are the key skills expected from graduate students to work on IIoT, preferably security perspective, so they can introduce an autonomous syllabus. He's calling in from the RV College of Engineering in Bangalore. So any thoughts
I can
on
take I can take a stab, and I know the other guys will have comments there. You know, I basically teach in 2 computer science departments, and the challenge in reaching across the fence to the industrial engineering teams is significant. You know, there's not a long history of interaction. There are very few courses that tend to do an acceptable job of covering both topics. So, you know, perhaps before we even come to some agreement on what graduate students or undergraduates should have, I think at the university level, there needs to be some realignment. I think there are some schools doing it. I'm at NYU and Stevens, and I can tell you that at our schools, there's still a great distance between those groups, and we're probably not the model to follow. But I hope it starts to happen, because unless we do see some cooperation between those groups, you know, you're going to have a lot of engineers pop up who need to go back and do remedial SANS training or IONS training or something, and the reverse. So security engineers coming out who need to go learn, you know, how a wind turbine works. So it's going to be a little bit of a bumpy road, I think, for the next few years in academia. Yeah, the other Mike, and you guys may have some opinions about that as well.
I think from my perspective, I am seeing a number of academic institutions start talking about IoT and IoT security. I know MIT has a program, University of Reno has a program, which we're part of. However, it's not part of the actual curriculum. And I think that's where we need to go, is it's actually built into the curriculum, as opposed to being, you know, a 6-week, you know, course or some sort of elective course you take outside of a normal degree. So I think we're not there yet, and I would echo Ed's commentary, is that that's where we need to get to, is we start thinking about security for things like system design engineering. It's just not something that I learned when I was in school, and now I think that's starting to cost us. So yeah, that's my commentary there.
Some great insight. I think that also addressed Tatiana's question, because she had a similar one around the academic side of things. I see we have a couple more questions coming in. There's one from Rajeshwar. It says, what kinds of underlying technologies are recommended to ingest, curate, and access terabytes of sensor edge parameter information to apply data science algorithms?
So we have a lot of experience in that, and our approach is, you know, we leverage standard off-the-shelf technology as much as possible. So all of our edge devices, which are constantly screening the data, are built on you know, industrial processors like those from Intel, and industrially available operating systems like security enhanced Linux. So those are the technologies that we've been leveraging to help our customers screen and reduce the useless data and find let's say the needles in the haystack, the good stuff that they can take action on.
Excellent. There was one quick one for clarification from Bala. Just could you please repeat the company information that did a good job in capturing operational KPIs? I can't remember who had that in their presentation, but
I think I mentioned PTC. Yeah.
Okay.
So P as in Peter, T as in Tom, C as in Charlie. If you look at PTC ThingWorks, works with an X at the end. They do a really good job of creating some solid KPIs and use cases with their partners like National Instruments, and how they are able to take the digital transformation from one period of time to another period of success. So I would encourage you to take a look at that.
Very good. Very good, gentlemen. Well, thank you. I think we may have time for one more question. It looks like we've got, let's see. This one's for Ian. It says, you talked about wireless as a sensor trend. That's a pretty generic term covering dozens of standards like Wi-Fi, Bluetooth, Zigbee, etc. How should people go about evaluating wireless standards for sensors with regards to security?
Yeah, that's a good, good question. So our philosophy is, again, really to drive towards leveraging standards-based wireless technologies that have security considerations built in from the ground up. You know, in our recent investments, we've been focused on Bluetooth 5. We feel that you know, has nice security provisions, but we don't stop there. We actually, you know, at the application layer are investing ourselves. You know, we partner with Blackridge. It's sort of our gateway layer to bridge our Bluetooth 5 network over to you know, the internet layers. And so our approach is to leverage standards and off-the-shelf as much as possible, and try to remove as much of the security through obscurity concepts that some people in the industrial, unfortunately in the industrial OT space, try to rely on. That's not something we think is an approach that will work.
Very good. I had one more question from a gentleman, Dan. He says, do you mean that IoT and IIoT are the same? I say that IIoT devices are linked to SCADA, while IoT devices communicate with cloud-based service. Can you explain? I think he was directing this one to you, Mike.
No, I think I consider IIoT more machine-to-machine type of environments. IoT, and this is just my personal view, IoT for me is creating identity or information and sending that to a cloud somewhere is what I would say. You know, a typical use case in IoT could be, you know, a Fitbit to a cloud as an example, or your phone to a cloud. Whereas in industrial IoT, the differentiation that I see is that you have more machine to machine and network machine to machine type of communication. That data still may go to a cloud, but it's data that is either derived or generated from a machine. Now, you still have people in the loop somewhere in that case, but that's how I differentiate IIoT, machine to machine, versus IoT, which could be, you know, data taken from a human being and then transmitted to cloud.
Great, thank you. Syed just sent one in here under the wire. It says, what are industry standards that we have to consider to deliver a market acceptable product for North America?
One more time, Greg.
Yeah, he says, what are the industry standards that we have to consider to deliver a market acceptable product for North American market? I'm not sure if he's talking about product or internet protocol or which specific.
I think a lot of it will depend on the North America market's a broad market. And in our experience, you have to understand the industry. So serving the U.S. military or maybe critical infrastructure is very, very different than serving, you know, an industrial factory. And understanding the different security requirements oftentimes is an industry by industry basis. So in the energy industry, they use a different set of standards than they do in the military. They both come from I think a common core set of beliefs, but their implementation strategies are slightly different. So you probably have to take it a little bit more on an industry by industry basis.
It's probably telling that that's not an easy question to answer. When we were all growing up, every one of us would have probably said underwriter labs, you know, in the 50s, 60s, 70s, 80s. It was very common, you know, agreement and acceptance on how you standardized and certified up, you know, some device. But you're right, it's complicated. I bet if you add them up, there's probably 30 or 40 standards that have to be tracked. So that's kind of a bummer, right? In our community, that you have to keep track of all that, because it's always different language, different terminology, different references, and it's easy to get them mixed up. So I hope that fixes in the next 10 years. That is a problem.
Absolutely. Well, thank you, Ian, Mike, and Ed, and thank you, everyone, for taking the time to join us today. Please stay tuned for other educational webcasts brought to you by IIoT World. May 30th, we'll be hosting a virtual conference entitled Monetizing IIoT, based on use cases in the manufacturing space. You can also secure briefings with our analysts and co-founders during up-and-coming events over the next 4 months. We'll be attending Viva Technology in Paris, France, May 16th to 18th, Spotlight on Innovation in Orlando, Florida, May 21st to 23rd, LiveWorks in Boston on June 11th and 12th, IIoT for Metal Formers and Fabricators, June 24th and 25th in Cleveland, Global IoT Forum in Chicago, July 9th to 10th, and Digital Industry USA, September 11th to 12th in Louisville, Kentucky. And stay tuned for other educational series focused on topics that range from industrial cybersecurity or how IIoT and artificial intelligence optimize industrial operations later this year. Special thanks to our sponsor, Blackridge Technology, for this educational session. And check out our upcoming events while our analysts will be present around the globe. And feel free to subscribe to our newsletters, YouTube channels, and follow us on Twitter at IIoT_world. This concludes our program for the day. Thanks for joining.